Hello, this is Keith Kreischer. I'm the Executive Director of the IoT M2M Council, better known as IMC, and it's my pleasure to welcome you all to track 2 of our IoT Days fall event presented by the IMC. I certainly hope that everyone joining us today is staying safe and well in these frankly dangerous times. The topic for this track is connectivity convergence, and that's between 5G, satellite, low power, and other formats. We'll have a 45-minute panel on that subject, followed by 2 10-minute presentations, one on IoT device security and another on how convergence is working within the enterprise. Before we begin, I wanted to cover a few housekeeping items. This webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure your computer speakers or headset are turned on and the volume is up so you can hear the presenters. An on-demand version of this webcast will be made available later today and can be accessed through the same audience link sent to you earlier. If you have any questions during the webcast, and this is important, you can submit those questions through the Q&A box on the right side of your screen. The presenters may not answer the questions at the end of each session, but please feel free to ask questions at any time during the presentations. Any unanswered questions will be responded to offline. We will have a record of your question matched with your registration, so we will get back to you, never fear. For those of you on the call here today that do not know the IMC, I thought maybe just a quick word of introduction would be a good idea. The IMC is the largest trade organization dedicated to the global IoT sector. Its membership is comprised of 25,000 rank and file adopter members who are individual enterprise users, product makers, and OEMs, and apps developers that deploy IoT solutions. They join the IMC for our content, which in addition to events like this, we are very active in conference programming for live events. We're the exclusive IoT partner for CES and Embedded World, as well as providing adopters with use cases, white papers, newsletters, and blogs. IMC adopters have to qualify for membership as IoT deployers, and that's important to remember. That makes us somewhat unique. The IMC's board of governors includes 35 of the most influential IoT technology companies that provide solutions in the form of hardware, software, and connectivity. They join the IMC for access to our adopters for purposes of thought leadership, lead generation, promotion, and research. We encourage any attending today to check out our website, iotm2mcouncil.org. And with that, it's my pleasure to introduce my good friend and colleague, Jim Morrish. Jim is a principal and founder at Transforma Insights. Jim, good afternoon.
Good afternoon, Keith. Thank you very much for that introduction, and welcome everybody to this session. So the first part of this session, as Keith mentioned, is a panel. It's a panel discussion, and of course, this is the track 2. It's convergence between 5G, satellite, and low power. There's a lot happening in this space at the moment in recent months and years, and some really quite exciting and interesting developments, quite transformative. So we'll be looking to explore some of those this afternoon, and just looking at that power of convergence in the realm of IoT, embedded systems, looking at 5G, satellite technology, low power solutions, and so on, and how that's going to revolutionize some of the connectivity options out there. So I'm moderating, as Keith mentioned. I'm half of the founding partners of a company called Transforma Insights. We're a firm of industry analysts, but I'm going to be facilitating this, not participating in this today, and I am joined by 3 panelists. In fact, you'll notice that at the moment we have 2 panelists. One of them appears to have fallen off the internet, but we'll hope to get him back soon. So my panelists are Brian Critchfield, who is VP of Global Marketing at Airgain, Jeff Noska, who is VP of High Bandwidth and Fixed Wireless Access at Core, and currently absent, but hopefully back very soon, Luke Vidal-Madjar, who is Head of IoT Solutions at BICS. So what I'm going to do now is hand over to each of these guys to make a quick introductory presentation, or just 2 slides about who they are, who the company is, and some of their thoughts on this topic. And first off, it is Brian. So let me just forward the slide over. Oh.
There we go. All right, I appreciate it. Thank you, and it's a pleasure to to be here and our work with the The IoT M2M Council is great. The content's great, and I learn as much from you as I can impart. But just a little bit about Airgain. We've been around for 20 years. Started in really custom antenna design, and then we've made a couple of acquisitions over the year that have really broadened our portfolio. And so today, now we're really kind of broken up into 3 sub brands. We have Airgain Embedded, which is all of our embedded products. So we have embedded antennas, embedded modems, development kits. So if you're trying to bring a connected product to market, we have a whole line of products around that. Airgain Antenna Plus, which is all of our aftermarket antennas. So you've got our fleet IoT, and now we've started getting into network antennas. And then Airgain Integrated, which is really kind of the revolution and transformation that we're making here at Airgain, is building more of these off-the-shelf or finished goods products that solve some of the common issues out there today. Our tagline is we simplify wireless, because that's kind of the common thread across all of our products and services that we offer, is how do we make getting connected as simple as possible for our customers. And as an example of that, one of the things our advanced development team set about trying to do is to solve the 5G customer experience gap. And here's just a quick slide on that of we're going, look, 5G is a wonderful technology. It's been around for a long time. We've heard about it for a while. But one of the challenges with 5G, great, low latency, great throughput, but getting the signal to you is difficult, because the higher the frequency, the shorter the signal distance. And so what we've done recently in our advanced development team is start to develop products and services that can improve that customer experience by delivering a better signal, and then being able to transform that signal into exactly what it is that you need at your home, office, or vehicle. So you can see, starting at the base station with some of the network antennas that we've developed. We're in the process of launching now 5G repeaters that are C-band repeaters that can help perpetuate the signal, whether it's at the network level or even in the SOHO level. Fixed wireless access devices, and I know we're going to hear a lot more about that too as well. But outdoor enterprise grade fixed wireless access devices, and then even vehicle mounted 5G devices too as well. So we're trying to really perpetuate that 5G signal wherever you are, and in whatever format that you need it. So that's just a quick blurb about Airgain.
Thanks, Jeff. Thanks for that introduction. Thanks, Brian. Thanks for that introduction. Next up, Jeff.
Jeff.
All right, great. Yeah, thanks so much. So yeah, real high level, right? Like, core is all about connecting, and really with this convergence, right? From the things you see on the slide here, right, is being able to have a one-stop shop for all the connectivity, but also just the advice and consulting and helping pull these things together, right? When you start looking at low power versus satellite versus 5G, and I use the word versus, right, because they're in competition. It depends on what your solution is, right? And as those are starting to converge more and more, being able to have experts in that field that can also deliver after that solution and design and all of that is met. So we have connectivity worldwide, wherever you might need it, on whatever technologies really are supported in those areas, right? So whether that's that satellite in the middle of the Sahara or 5G in downtown New York, right? And being able to pull those together. And with that, just our ability to help you select, build, align, and really scale, and then support whatever that solution is that you're pulling together. And our goal is to demystify the connectivity piece and being able to be a one-stop shop instead of building relationships with different providers across the globe.
Okay, thank you for that, Jeff. Thank you for that introduction. And next up, Luke, who has rejoined us. So welcome.
No,
Luke.
hello everyone. Sorry, for me I was still on stage. It's strange, I disappeared for you, but I was on stage. But okay, anyhow, hello everyone. Good morning, good afternoon. So I will start by a quick introduction, 1 minute on BICS. So for those who don't know us, I think the majority of you, we've been a market leader for international connectivity for more than 20 years. We work with the majority of telecom operators globally. Indeed, very few people know us, but actually every enterprise and even everyone is using our services. Typically, when you travel, you use your connectivity to support your mobile devices. So today, typically, we carry more than 50% of the worldwide roaming traffic on our infrastructure. So in a way, we are really the international network behind mobile operators globally. And a few years ago, we have extended this international connectivity proposition into the IoT space by becoming global MVNO for IoT. And here we want to be somehow the best fit partner for any enterprise with international IoT project. And our core product on this market is called SIM4Things. So then I have a second slide that there is some animation. Oh, no. Okay, it was not the full slide. I don't know how come. Well, okay. Okay, so anyhow, what I want to set the topic today, this is I will see that more into a broad picture of digitalization of the enterprise business. So what I draw into this slide, which you can't see here, this is how business are becoming more and more connected, and how this digital transformation somehow drive enterprise to connect everything and everywhere. So I had an example. It was on the left side. It was the example of I wanted to draw a picture of an enterprise with all their connectivity requirements. Took an example of an industrial sector. Let's say, for example, a company doing some waste management. So they do some their factories. So they deploy mobile private network into the factories in order to support an optimization of their manufacturing process. So inside these factories, they would use typically 5G, because today in many regions, 5G is a technology for private networks. Then they have logistics. Typically, they could have several factories, several plants, and then they have trucks, a fleet of trucks going in and out of and between the plants, and then these trucks will connect over traditional 4G networks. Then they sell some smart waste management solution, typically containers. They put a sensor into the containers, and as containers can be deployed anywhere outside, outdoors. So there is no easy power supply. So they need to use low power networks, normality, LTM, LoRa. And finally, as well, they could ship their product around the world, as they could sell it. And then during this shipment, going overseas, going across the oceans, use satellite connectivity. So for a single enterprise, you see across their business process, across their business requirement, there is somehow a need to converge solution to support the different technology into something manageable for the IT teams, for the operational teams. I think this is a good perspective. This is how the digital transformation of enterprise are making somehow the convergence of solution a requirement. And I don't know why the slide was so empty. Sorry.
It's okay. Don't worry. I'm reliably informed that all slides are available to download, and that as handouts for the audience. So guys out there listening in, you can download it and see the full version of Luke's slide.
Okay.
Thank you for that introduction, all of you. And it's a really interesting topic. But let's just spin back to start at the beginning of it. So which connectivity technologies is it that are converging, and how are they converging? And look, do you want to start with that?
Yeah, so I think the base of the convergence with our mobile technology. I will start with that, because that's somehow the beauty of mobile technology. It's the only technology that provides really true global coverage by nature, because you have mobile network in every country, and nationwide networks, except remote places, but national network are there. So it's already the start of the convergence. This is the fact that it's easy to find the radio coverage of this technology. The good thing on top of that is that the mobile industry having somehow good enough or creative, innovative enough to follow the trend. So we know low power network have been invented by Sigfox, but the mobile industry have been good enough to follow that and to develop technology that deliver low power network, like it was invented by this new technology, Sigfox and LoRa. So you have normal IoT and LTM, and now we see coming into the market some first release 17, 3GPP release 17 satellite constellation that allows regular mobile devices to connect on narrowband IoT with satellite. So it's direct narrowband IoT connectivity to satellite. So I see that at the end we are on the path to enable through a single mobile devices, very simple. Huh? It can be a smartphone, it can be an IoT device, the possibility to connect across all this panel of technology. The traditional 2G, 3G, 4G network, the low power networks, narrowband IoT, and satellite.
Okay, thank you. I mean, that's an interesting perspective on convergence. What about other aspects of convergence? I mean, either Brian or Jeff. I mean, there are other technologies in there. Luke mentioned Sigfox, but there's also LoRa and various other connectivity types, and there are different spins on satellite as well. Brian, do you want to?
Sure. Yeah, it's interesting. I think we, in our circles, like to talk about technology, but the user doesn't care. I just want it to work, and I want it to work seamlessly all throughout. And so I think it's really on our shoulders to figure out how to get these technologies to work together to deliver that user experience. And so, I'll use an asset tracker. Now, our background is cellular, so we kind of default to that as our backbone, everything from NB-IoT and LTE-M all the way up to 5G. But that being said, when we develop an asset tracker, we go in with cellular and we say, hey, this can replace RFID tags and whatever else you're using, because you don't have to set up the infrastructure. You can just use the network. But then you've got battery questions and you've got data costs and you've got all those things. And so we've actually built asset trackers that can act as a BLE gateway and be able to, use BLE tags all around and then go through the asset tracker, use cellular as the backbone. In that same asset tracker, we use, Wi-Fi, GPS, and cellular for triangulation purposes, right? GPS can tell you exactly your spot. If you're driving down the road, GPS can tell you exactly where you're at. Wi-Fi will tell you the side of the road, and cellular will tell you you're in that field over there, right? So, I mean, that's being able to converge these technologies. And so we default to cellular, but then you add on top of that, well, what if I don't have a cellular connection? What if I'm, for instance, transporting a container in the middle of the ocean? What am I going to do? You can layer in now satellite on top of that. So I think users are kind of depending on us to figure out how to get all these technologies to work together to deliver that user experience that they're looking for.
Yeah, so that's two perspectives on convergence. There's the convergence onto cellular as cellular does more and more, and then there's convergence from the end user perspective, who just wants connectivity and to some extent they don't really care how that happens. I mean, there is complexity under there, but they just want all of these things connected and they want them to work, and it doesn't need to be cellular. Cellular plays a role. Brian, what's the mix between these things?
I mean, we can definitely always.
I'm sorry, that was a question for Jeff. I'm sorry.
Jeff, okay, all right. I think you've been mixing Jeff throughout kind of the whole discussion here.
Yeah, and it really depends on the technology, right? So I spend most of my time in the higher bandwidth, higher throughput, right, where an asset tracker might need, at least historically, and the data requirements are going up and up, but a data tracker might need 1 megabyte of data, and I'm working with solutions that need 10 megabit of constant upload speed, right? And so as the future promise, right, with IoT, machine learning, some of the advanced things that can be done with video want to get pushed, one of the challenges with convergence is the fact that it's location dependent, right? So I'm looking at things like, say, on the satellite side, the Starlinks of the world, and being like, okay, so that's a future state. We're not there yet, right? But 5G is definitely getting us there, but that coverage isn't ubiquitous yet. And so one of the things that I focus on a lot is helping customers understand what's possible and what's not, because the question becomes, right, like, oh, but my iPhone has satellite in it, so, and it's 5G, so can't I use that for my AI, right? One of the challenges that we see is that there's this promise of really cheap edge computing, and I think that's true in a lot of senses, but not for AI, right? Like not for making very complex decisions. That's still a very expensive proposition to put on the edge. And cloud compute is still getting cheaper and cheaper and cheaper. So I need to send all of my data, all my data points back to the cloud, which 5G is starting now to truly enable. LTE can be good enough sometimes, but then there's challenges with satellite in that regard, right? And so I think on the lower bandwidth, the convergence is going awesome, right? And there's new entrants into the market that can connect up everything and anything and get the data up. When you move into the higher bandwidth stuff, the stuff that's really interesting, the stuff that gets people excited, the stuff that the carriers talk about, and we all want to talk about, right? Like weapons detection and facial recognition and all those sort of things. It's really setting expectations with customers and helping them to understand that when they deploy this new technology, we're not quite at a place where everything just works. And so sometimes the convergence isn't there on the most innovative solutions that require that higher bandwidth. But on the flip side, being able to grab just tens and hundreds and millions of data points from those low power bandwidth type solutions, the LoRa's of the world, and then just having connectivity on the satellite and the cellular, I think we're in just an awesome place in the market. On the future promise, we're still working on it to get there.
Yeah, thank you. And I just want to pick up on that satellite piece. And Brian, I mean Brian, this time. Just focusing a little on that satellite piece. There's a lot, because this is the really new piece, I think, or the new rapidly emerging piece. Historically, there's been lots of different flavors of satellite. There's been GEOs, MEOs, LEOs. There's a lot more LEOs going up at the moment. Now we've got direct satellite protocols, emerging across various types of protocol. And of course, there's the old style via gateways. So how do you see this space emerging?
Yeah, I'm not the expert on satellite. I'll be upfront and honest. I think it's still an emerging technology that we're seeing out there, and it's still continuing to evolve. That being said, we're very much in talks with various satellite companies to figure out how do we integrate that technology, because again, when you go into each of these wireless technologies, they each have their purpose and features and benefits, as pros and cons on all of these, and the benefit of satellite is the ubiquity of it, right? So if I can get connectivity everywhere, that's great, but it also has a lot of cons where you don't want that to be your main backbone. So I think that's what I would say is it's still emerging. And we're still trying to figure out how to integrate all these together. But I would say within the next year, you're going to start to see products which have multiple of these technologies, including satellite built into them.
Okay. So Luke, I'm just taking this a bit further. What about? I mean, I've heard the satellite almost positioned as another roaming zone for cellular for some of these lower bandwidth technologies. Have you heard it referred to in the same way?
Yeah, but this is what we do actually. Yeah? So we have integrated the satellite constellation into our global coverage through roaming agreement. So I see the question as well coming. Yes, traditional roaming will be the easiest way to enable connectivity on satellite network. But we also have the possibility to enable roaming without being completely a GSMA standard. So this is somehow what we also do when we integrate a mobile private network into our global footprint. We have some solution to integrate the private network into our global coverage. So it's not a requirement. But yes, so at the end, the idea is anyhow, with all the benefit of using a single global SIM card roaming everywhere, because then if you are familiar with the mobile technology, when you use roaming, the very big advantage is that all the data traffic is flowing back to the same central platform, what you call the home PDN gateway of the central. And then you can really control everything around the service you deliver to the enterprise customer, regardless where they are, being on satellite, being on low power, mobile low power networks, being on 4G, 5G. is a single platform that somehow capture all the flows from anywhere, and you deliver a single service, a single portal, a single. You can also pull all the data into the same data application. It's a single pane of glass. It's simple. So yes, roaming for us is a way forward to enable that convergence, including for satellite networks. Wow.
Okay, thank you. And then I guess, so having covered that baseline of actually what is converging, what does the fusion of these technologies unlock in terms of possibilities for the seamless connectivity and the use cases and the automation and various things that enables? Jeff, do you want to start with that?
Yeah, and definitely. And one of the I'm usually focusing on the challenges, again, because my primary focus is on those high bandwidth and high throughput. And I think, Brian and Airgain and people like that are become more and more important because the outdoor antennas, right, being able to talk to the satellites, being able to talk to everything. And so when you think about pulling those together, right now it's primarily focused on, in my world, right, it's primarily focused on the fixed asset, right? So Luke's talking about the mobile and pulling all of that together, where I'm much more focused on the higher throughput, which right now is still fixed. But we're in this place where that's becoming mobilized very quickly, and to Brian's point, like in the next year. And then as we're able to, these technologies that are coming out that are in the fixed space, take something like weapons detection, right, or facial recognition, something like that, that really requires all of that throughput. As the technologies start to grow over the next, again, I think it's in the short term, right? You've got to be there right now, building it in the fixed, so that way you can be ahead of the market, right? And that's obviously important for the audience and the people here, right? If you're thinking about what's going to happen in 3 years, you have to start playing with it now if you want to be a market leader. But being able to pull together what's in the fixed space that can talk to a satellite network, that can talk to a 5G network, as the technologies become more and more ubiquitous, transitioning those into that mobile play, and or taking the mobile and upgrading it to be able to take advantage of these technologies, is where I'm seeing, right? There's parts that are fully integrated, and there's parts that are still coming out, and we're still in the infancy. I don't know if that actually answered your question, but that was top of mind.
No, it's great, thank you. And Luke, do you want to talk about some of the new opportunities that are unlocked by this kind of converged connectivity future?
Yes. So for me, I will still put that into really the perspective, as my introduction, the digital transformation of enterprise. So you have all these companies that connect everything everywhere across their business process, their customers, their assets, and from there, at the end, connectivity is not their core business. Their core business, this is their product, their business process, their applications, and when you have this family of technologies that they need to master on the connectivity side, it creates some true challenge. So if I compare to when we started being a global MVNO at BICS about 10 years ago, now connectivity is becoming more and more complicated for enterprise. So where I will really see the opportunities, at least for a service provider like us, is to work on bringing simplicity for enterprise to manage these different technologies, so that all of these technology bring some value to their business process. So private 5G network from a manufacturing plant, narrowband IoT to connect their asset outdoor, etc., etc., etc. So there is a requirement and a real need for enterprise, for company like BICS and others, to make this deployment manageable. So it starts with a single connectivity management platform. We spoke about it, using roaming to have a single management tool for all their devices across all their use cases, across all the technologies. And it's also maybe some higher layer platform, typically connectivity is just a piece of the IoT solution. And remember, the enterprise has many IoT solutions. They have the manufacturing process, their logistics, etc. And each IoT solution is always made at least of 3 parts. There is the device, the connectivity, and the application. So imagine, the growing complexity for enterprise to manage all their IoT projects. So there is also, I believe, some need to bring to enterprise some simple single tools to manage their diverse IoT deployment across the different layers. So it typically could be digital twin tools, where enterprise could for each of the IoT deployment build a single view of each of their IoT device on the field. A single view with the connectivity being our modality, etc. A single device view with all their functionalities, and a single application view. That's my I think there is a lot to bring to enterprise to make this all this diversity of deployment manageable.
And
I'll add to that, Luke. And go ahead, Brian.
I was going to chime in too as well. From a use case standpoint, it seems like the biggest demand for convergence is really in mobile applications. And I know Jeff was kind of making this distinction between the two, but as you move, you move. We'll take asset tracking as a great example, right? I think asset tracking, condition monitoring are two use cases, and that's very broad, but across the board, not just location, but what's the temperature, what's the humidity, how's it moving? Is it tilting? Is it, is this full or empty? All of that, and as it's moving across different connectivity, capabilities, I think that's where the greatest demand for convergence is coming in, is, especially if you need real-time access to that and it's moving, across country or across the world. I need to make sure I'm connected to that asset at all times. I think that's where you see a lot of the use cases that are driving this demand for convergence. So I'll throw it over to you, Jeff.
Yeah, and I think just what both of you guys are saying right there is vital, right? It's incumbent on all of us as people in the IoT industry, the members of us that are of IMC, right? That's everyone on this call, is to build solutions and to simplify, like what Luke was talking about. So it's not just that the person who does asset tracking, right? Like it's creating simplified solutions across the board. And what really excites me is being able to get those simplified solutions to people who have no interest in connectivity, right? They're focused on whatever their AI application is, or whatever their logistics application is, or their smart cities, or their automation application, and they're experts in that field. And then we can bring them as an industry something that is as close to plug and play as it can be based on their particular use case and their scale. That's the connectivity, the hardware, the antennas, the certifications, the expertise, right? Because so many of our customers, they don't want to be experts in cellular. In fact, they want to have nothing to do with it. They want to have nothing to do with satellite. They're just like, just get my thing connected, right? Because I know how to do what I'm doing. I just have no idea how to get the data back to me. And so as far as new possibilities, I'm excited about the people who aren't in IoT, who are building amazing applications that only work when it's connected. And then we bring them the solutions as an industry that empower them to come up with new things that we haven't even thought of yet.
Yeah, absolutely. We're focusing very much on all the different technologies coming together and just working, making that connectivity simple for the end user to adopt and say, I want to connect this device, and it just works. There is, though, some remaining complexity. I mean, you touched on some of it, Jeff, when you were talking about AI and running that over low power devices. There are some challenges there. It works on devices which are connected in some ways, but not connected in other ways, and possibly as these devices move from different areas of coverage to other areas of coverage. And Brian, you mentioned some quite complicated combinations of connectivity. So these are going to have implications for what you can do with an end device, the information you can get off it. How do you think that's best managed? I'm just going to throw that open to anyone.
Education, working with the end users and helping them to understand what's real and what's not, what's been promised in marketing and what's real in the field. I think many of us here will remember, when you had telephone lines running alarm systems, say for a fire department, right, and opened their doors and dispatched everything. You had these devices that were built on telephone lines that had no throughput, essentially to them whatsoever, but they also had no latency. They had 2-3 millisecond latency across the entire city. And then you throw a cellular device in there that now it has 100 milliseconds and the whole thing just breaks down, right? And so when you're talking about 5G at 20 milliseconds or satellite at 200-300 milliseconds, educating the end users and the people building the full applications of what's possible as you converge and you get ubiquitousness of coverage, there's compromises that have to be made, and helping customers understand that, I think, is that just that education piece is really key with whoever's building the end technology.
I would agree with that too as well. I also think RF and connectivity is black magic to most people. You know, even engineers, even your electrical engineers, we see this as we design our embedded products. You know, I've built this product now. I don't know how to do the RF, and I don't know if I want to figure it out. And so I think it's a combination. It's really a partnership between manufacturers, service providers, and system integrators to really come up with those solutions to deliver the market, so that just, you know, I don't need to worry about it. I know it's just going to work, and you guys figure it out for me. I think, you know, we've all been very used to kind of swimming in our lanes in the past, and I think that we're going to have to come together and figure out how to work together as frenemies, or whatever you want to call it, to deliver the right solution to end users. And we're seeing that happen more and more. There's a lot more co-opetition going on in the market.
Okay. Luke, your thoughts on how to actually manage that complexity and convergence, and how to educate those end users to build things in an appropriate way.
Yeah, we start with you're correct. We start with the design of the solutions and a plan by enterprise of how they will go into their digital transformation, go into their connecting more their business. If they go in different direction for each of their projects, they will run into a very high challenge. So it's part. It's even I would say should be part of the strategic plan of enterprise. How do I go further into my digital transformation? How do I get my business connected? There is so much, there is so much possibilities, technology that very quickly you go into challenging projects. And we often see IoT projects that fail after several years of prototype and validation, and then they realize that they didn't start on the right foundation, and they need to restart everything. That, well, I would say this is yes. It's a long-term transformation. It needs to be strategized by the enterprise.
Okay, thank you. And the other thing to bear in mind is that this convergence of networks that we're seeing at the moment, this is not a stable state. All of these technologies are emerging and evolving, and in particular, as has been discussed earlier in this session, cellular technologies are continually evolving. 5G is getting rolled out to more places. So I guess that brings a question, such as how do you, to Jeff, so how do you build for a 5G future when not all of the technologies will support that 5G future? 5G isn't everywhere. You have to deploy on maybe one combination of technologies and migrate over time. How do you go about that, Jeff?
I'll go back to the education piece, and it starts there, right? Is helping enterprises, helping developers understand what the differences are, and also helping them to weed through the marketing, right? Like everyone who's building the solution wants to talk about all of the future possibilities. Like, we'll take 5G for a second, and network slicing and massive IoT and low latency slices in the network. Well, that's all great, but I think those exist in like 3 pockets around the world right now, and very small pockets, right? Like the MNOs haven't developed those out fully yet. And so you have hardware manufacturers and marketing people talking about these amazing technologies, and they are when you see them actually used. But to actually understand what's real and what's not real, and the key is to start working on what's real. if you want to be a market leader, if you want to be out in front, if you want to transform, or just your own enterprise and transform your own enterprise, right? If you're not making products for the rest of the world, is you have to start today. To Brian's point, that RF is black magic and cellular gets really black magic. The further you go down the rabbit hole of how the technology actually works, like it just constantly blows my mind how we're squeezing that much more out of, you know, a 5 megahertz spectrum bandwidth at whatever, right? Like it just blows my mind how we're getting so much out of that. And so building for today and getting that institutional knowledge as you're deploying on what's possible and what's real, preparing for that future. Because if you're not building on LTE as an example, or the 5G that actually exists, and noticing the differences between a 700 megahertz and a C-band type of, and even millimeter, and if probably don't want to develop for that, but you know, it's understanding those differences today and seeing those will give you that institutional knowledge that'll give, you know, the enterprise or the consumer goods producer, right? Like it'll give them a leg up, and they'll be ready when those technologies actually exist. Because if you wait for it, there's other people who are already developing for it, and they're going to have that understanding of the real and what's really possible as these future iterations come out.
And I'll piggyback off of what Jeff was talking about too as well. I mean, you look, obviously we're the IoT Council, and so in IoT, there's not a lot of great use cases for 5G right now. Most IoT can be tackled using LTE and some of these other, other technologies. But video now is starting to become more and more prominent, so it's driving this 5G question. I'd say the same thing. You know, Jeff brought up millimeter wave too as well. Same thing. So we build products. We build a lot of LTE type products, but now when we're getting into 5G, we're not going millimeter wave because again, use cases right now are pretty minimal. We're really focused on C-band. So again, it's how do you deliver what the market needs today while still preparing for the future? And I think that's a challenge with a lot of these technologies too.
Yeah, and just even the amount of data that's needed, right? Like you start working with machine learning, and there's customers that all they can afford is, let's say, 10 gigabytes worth of data for their application. They wish it were 10 terabytes of data, because if they could just grab, instead of grabbing every 1 minute or every 10 seconds, they could grab every second or every 200 milliseconds a different point of data. That just makes their algorithms work and their predictive models work even better. And so one, the throughput's definitely a thing that is needed to increase, but also just the costs of running the networks. And so there's a lot of pressure from, and to the previous question, right, is like, how do you move into these things? Is there's people who are used to grabbing data off of the landline. They've got a gigabit fiber connection, and that's what they built their technology on. And they're like, okay, we're going to go mobile, or we're going to go into the fields in Nebraska, and we want to do the exact same thing. Well, the technology might actually support it, but the economics don't. And the cost of antennas and getting that data back in don't. And so this kind of goes back to building with what's possible today and learning how to tighten your algorithms, right? Working with many customers who are like, oh, we need a terabyte of data. They do the full due diligence and they realize, okay, we needed 150 megs, right? Because they just get better at programming for those things. They understand, okay, I don't need to upload the entire data set every 10 seconds, which we see all the time, right? It's like, okay, I only need the incrementals, and maybe I can offload and spend an extra $100 on the hardware to give a little bit of edge compute to be able to know what actually needs to be sent. And the key there is to be working on that today with what's real today, so that way, as the new technologies increase, you're ahead of the curve.
Okay, thank you. So I guess there's a consensus to make sure you move quickly and use the new technologies as they're available. We're getting towards the last few minutes of the session. I just wanted to touch on a theme which recurs frequently. How do we manage security in these new converged environments? Luke, do you want to start with that one?
Yeah, so yes, when we speak about diverse deployment, it just means, as we said, a lot more connected devices, a lot more, at the end, points of attack for enterprise. We all know that we are all IoT domain experts. Every IoT device on the field is a point of failure for the enterprise. So we are all running into a world where we see statistics, hundreds of millions of attacks every year ongoing, like 50% year. So what can enterprise do? I will say one key perspective around security is that you need to have as much as possible a single framework to manage security across all your deployment as an enterprise. Yeah, the more you have different technology, different application, different hardware, the more you need to have something as unified as possible. It's really the first advice to control security around all your IoT deployments. And on this aspect, I believe the mobile industry has developed a very interesting technology. It's called IoT Safe. Is to use actually the SIM card into the IoT device as a root of trust for the end-to-end IoT solutions. And since as our perspective, we see mobile technology as a core technology to enable this convergence. Speak 5G, LPWAN, satellite. There is here also a possibility to, one reason more, to use a SIM card as this secure element for IoT deployment. From then, the enterprise has a single solution, a single protection of the IoT solution across all their deployment, and it should be a best practice for the enterprise to be more successful in protecting their infrastructure.
Okay.
Yeah, I think security just has to be at the core from the development process, from the early thought processes, right? The early developers, they love having everything open because it allows them to do the most integration and the most ability to look at things. But if they're not thinking security at that first, I bought a dev kit that's got a SIM card in it, and I'm going to do all these cool things. If they're not thinking about security at that first level, so many times we've seen all of a sudden now there's 1 million devices deployed and they never went back and secured it. And so you have a target all over again where you have a Wi-Fi device that just never even got turned off, right? That now is a point of entry back into the network. So making sure that the developers at the very earliest stages are thinking about security. And even if they do turn them off to just play, it's like, okay, this is still vital. It's a key checklist. You have your team ready to go on the security side.
Absolutely. Brian, any thoughts closing thoughts on security?
No, I think Jeff and Luke covered it very well. I mean, obviously it's a growing concern, especially as we hand off from one connectivity technology to the other. And I think they tackled it pretty well.
Okay, well, in that case, thank you very much to the three of you. Thanks for that panel. Very interesting panel. So thanks to Brian Critchfield of Airgain, Jeff Noska of Core, and Luc Vidal-Madjar of BICS. Thank you for that. We're moving on to the next session, which is a spotlight. It's securing IoT devices with PKI and certificates. It'll be a presentation given by Ellen Bain and Mitch Mershon of Keyfactor.
Hi, everyone. Thank you very much. That was a great session. My name is Mitch Mershon. I'm a product marketing manager for emerging markets, which is IoT for us here at Keyfactor. And I'm alongside Ellen Bain, who's our SVP for IoT strategies and operations. And I think the last topic there really hit home with exactly what we're talking about. And that is that as we talk about security, all these different devices that we were talking about today, whether they're initiating the communication, whether they're the backbone of the infrastructure of the communication, now everything is moving data. So every machine, and by this, we mean every IoT machine. It used to just be servers, laptops, cell phones. Now we're talking about wind turbines. We're talking trains, planes, and automobiles. All of those identities must be managed as well. And I just want to call out a couple of the key points that were mentioned today. Is the one that really stuck out to me is as they're talking about to IoT developers, we're not experts in the field of cellular or satellite. Just get me my data. Well, it's the same thing whenever it comes to security. All of these IoT developers, they're experts in their domain, but whenever it comes to security, that's an area they're not so familiar with. So that's why you have companies like us here at Keyfactor to be able to come in and really help out. And another name that was dropped, I heard IoT Safe. That is something that we are very aware of, very involved in, and already compliant too. So we're able to bring all of this together for those IoT manufacturers. And with that, I'm going to hand it over quickly to Ellen to talk about security being a differentiator and now being a requirement.
Yes, thanks, Mitch. So obviously we've been talking a lot today about 5G, telecom, and so on and so forth. And the comments around security, how important it is, because we're talking about millions and millions, if not billions, of devices that will be going out there to enable new applications. And there's statistics that you can read that talk about how executives and leaders they believe that 5G is going to become the most critical enabling technology, but they're also afraid that having a compromise or having an incident is going to be negatively impacting brand and competitiveness and so on and so forth. So that's why we take such a sort of serious approach and a holistic approach to security, not only in telecom but in these industries you can see here. And so we are following these standards groups. Regulations are coming out, and from a security standpoint, I think the key to this is really understanding how to make sure that your entire framework, you have a security framework of edge devices to gateways in the middle to network appliances to servers on the back end, and then you figure out exactly what trusts what within that framework. So if we go to the next page, Mitch, from a product perspective, there's obviously, if you are a designer or a developer of these edge devices, whether again you're a sort of consumer device or a commercial device that's going to then be placed and used within this 5G network, you have to think about security from the start of that, as well as when you're manufacturing the device, how do you actually put security inside of that? Or then when it's deployed into this network, likely it is something that is your end customer is buying several of these devices, they're commissioning them. How do you do that in a secure way so that then you can trust who can access that? Because in some cases, the original manufacturer needs to have access to that device if it's running software, and they need to be firmware updates securely so that malware isn't pushed out. But then there's also applications that an operator would need to then place on the device to have it run securely within the network and to perform the functions that it's intended to do. So then this sort of continues on throughout the whole life of the device and until eventually you're decommissioning it. So there is a security thread throughout all of this, right from the initial identity and how you manage and what can trust and talk to that thing, all the way through how you manage it throughout its useful life to when you ultimately revoke it. So diving quickly into some details about what really established that trust, it is really around the use of digital certificates as a digital identity that uniquely is given to each of these things that needs to be connected to. So I'm going to talk here on the left-hand side. It's really about understanding what devices within this entire network can handle or can take a certificate, can enroll for a certificate. CMP v2 is used commonly for base stations, I know, within telecom systems. So it's really understanding what technologies are available to be used for initial provisioning, and then being able to have an extensibility to connect into other applications, to other systems that, again, I think someone mentioned it previously, this is an ecosystem. It is not one person developing all the technology that's going to be used. And so being able to work collaboratively together is really important. And then lastly, management of these identities is important. So we basically create and build public key infrastructure, PKI, which is comprised of several different certificate authorities which are issuing these identities. So it's all about how do you build, how do you manage that, and how do you centralize visibility of it. Mitch?
Thanks, Ellen. So other things that need to be taken into consideration whenever you're looking at doing something with PKI and certificates is a level of architecture flexibility. So whether you need something on-prem, we're going to be talking a lot about cloud as we continue to move forward. So all these different areas are going to come into play as we look at manufacturers. They have different security requirements at their facility than somebody might have in their own cloud versus a SaaS offering. So sometimes you just want that easy button, which is you hit the button, and it's that black box that we were talking about where all of a sudden I just have all my certificates, we're able to put them on. And that just balances out with a level of knowledge and expertise, as well as how much people want to handle. And that also goes with scalability. You need something that's going to be able to scale if your business takes off. Or as we continue to talk about here, the number of IoT devices out in the world is just booming. So as designers are thinking about this, they need to be able to say, all right, I'm making 100 today, but what if I have to drop 10,000 of them tomorrow? Well, you need something that's going to be able to scale up quickly. And Ellen's already touched on it a little bit, but compliance, security, and services. Just taking a look at all the different standards that are out in the world now. There's two types of products. There's those that are under standards or those that are about ready to be under standards. So making sure that you've got a flexible solution that's going to be able to meet all of these different standards. And as we're talking security, what we're really seeing inside the market is X509 certificates being the base of security as we start talking about all these communications. So we hit you with a bunch of information here about PKI, about certificates, and a little bit about Keyfactor itself. But we actually just wrapped up a survey, and this survey had 1,200 respondents across the entire world. And we'd love to put this report in your hands. All you have to do, you can scan here to get the report itself. You can scan also on the right-hand side there where Ellen and I will be doing a full deep dive into the report. So it's going to have some trends in IoT security. I also recommend checking out over in the handout section. There's an area where you can get an essential guide to evaluating PKI. If you need something higher level, there's 5 guiding tenets of IoT security. And then if you want to get a little bit deeper, there's 8 steps to IoT security. So I'd like to thank everyone for taking the time to listen to us today. Thank you, Ellen, for co-presenting with me. And if you have any questions, please feel free to reach out to us on LinkedIn, through the Q&A, or through the chat. We're more than happy to help with any information that you could want on your PKI certificates and more of the securing the IoT communications platforms. I believe you're on mute.
Yep. Thank you very much, Alan and Mitch. And for the prompt. It's certainly a key area. Security is fundamental to all of these things, and increasing in complexity, as you point out, as the number of devices increases. What I'd like to do now is introduce a presentation which will just round off this session, and we have Daniel Kont, who is VP and General Manager of Gateways, Routers and Modems at Multitech, and he will be talking about the digital enterprise and wireless technology convergence. So I'll hand over to Daniel.
Hello, everybody, and welcome to IMC Days Falls. I'm Daniel Quant, coming to you from Multitech's headquarters and manufacturing facility here in Minneapolis. And today we're going to be discussing digital enterprise wireless convergence. So wireless convergence refers to the integration of various wireless technologies and communication networks into a unified and seamless system. This convergence offers several benefits across various domains, including the telecoms domain, the information technology domain, and the data applications, data science, and AI domains that sit above that. So big shout out to Robin and the guys at Beecham Research. They've been doing this research now on how enterprises are using wireless technology in their IoT applications for a few years. And no surprise, cellular connectivity, top of the list, being used out there in public networks to connect various different mobile and static assets. Increasingly now moving into the enterprise, into their own wireless private networks. Wi-Fi connectivity, I think, is probably used by, 99% of all enterprises. But here we can see that enterprises are using Wi-Fi in their IoT applications as well. LoRa is now taking much more of that market share of the sensors, now coming up to almost a quarter, and we've seen that growing in this survey over the last few years. BICS actually has LoRa outselling other low-power wireless access technologies by 2 to 1, and with a CAGR growth rate now of over 30%. So it's interesting to see how there's a mix of technologies, and it's the enterprise themselves are not that interested in the wireless technologies. They just need reliable, seamless connectivity of those assets at the right cost. Clearly, 5G is addressing that broadband connectivity. And Multitech was a leader in 5G, having put devices out into the market as early as January 2021. And that went into DoD, government trials, logistics, transportation, outside broadcasts. So it went into a lot of different segments of the market. The enterprise was looking for low latency. It was looking for improved uplink performance. A lot of the assets that an enterprise has are out there bringing data into the enterprise rather than consuming data. And of course, in many markets, the regulators have zoned out liberalized shared spectrum for 5G use. Germany and the Bundesnetzagentur is a great example of that. But still today, with cellular deployments, both public and private, the sweet spot is LTE in terms of pricing and availability. It's interesting to note, though, that when it comes to massive machine connectivity, and 75% of those machines are sensors that are sending small amounts of data infrequently, this is where we see LoRa outperforming the market. So let's have a little look at a few case examples here. So robotic equipment, we worked with an auto manufacturer up in Michigan who was connecting a lot of these robotic equipments using Wi-Fi technology. And I'm sure it worked really well at the beginning, but of course, as the volume of those assets increased, the saturation of that frequency got so high that they have to keep rolling out more and more access points. The vendor that we worked with that did the 5G deployment, they managed to get that down to a 10-to-1 ratio of access points. So not only is that a better utilization of spectral resources, it also becomes lower cost and it becomes more reliable. So this is a great example of a transition from Wi-Fi that incubated these use cases and applications into cellular that really takes it into scalability. Another application is autonomous forklift trucks used in distribution centers, shipping, production facilities, and 3POs. It's not easy to find staff. It's a dangerous job. These vehicles can work 24/7, and they can be operated by one guy operating 5 or more of these. Very much a similar approach. The first few, I'm sure, worked well with Wi-Fi, but to really create a scalable solution of many of these AGVs all working at the same time, this is where we've seen a migration towards cellular technology for improved operational efficiency. So we've seen how Wi-Fi and Bluetooth services that short range with high bandwidth and broadband data. We've seen how cellular is taking broadband assets and bringing reliability and improved coverage and control to those applications. But with Convergence, we also now see how LoRa is taking the small sensors, the actuators. Like cellular, it has long range. Cellular does that by really shouting out loud, using a lot of energy and a high amplitude signal, whereas LoRa does that with a very low level signal with great immunity and coexistence as well. So it can run on batteries for years and years versus our cell phone, which we obviously have to charge up every night. Range is measured in miles, battery life is measured in years, and the cost is very low. And that's super important because if we're going to deploy loads of these sensor assets, real massive machine connectivity, then we need a good price point. Why are enterprises deploying that many sensors? Well, they're using data from those sensors around environment, proximity, temperature, flow rate, pressure, in order to automate their control systems and automate their operations with a more data-driven approach to that automation. So let's look at a couple of examples. You may have noticed that your supermarket is becoming increasingly filled up with refrigeration units, and in there is high margin TV dinners and exotic foods. Most all of the supermarket chains now are putting sensors in those fridges in order to measure the internal core temperature of that food. Just by being more accurate about how they monitor that temperature and maintain that temperature, they can have an 8% savings in their electrical bills and sustainability targets around that. They have 15% less waste reduction, because as soon as those temperatures start to get closer to a tolerance level, the issue can be addressed before having to trash the food that's inside there. And it also provides a simplified operation across all the stores. Not all of these fridges are easy to get into. If you imagine the ones in the back office, in a quick serve restaurant or in the back of a supermarket, they're metal fridges, and it's not easy to get a signal in there. So LoRa really is excelling and scaling in super high volume into these applications. Most commercial real estate companies are now bringing water leak and shut-off sensors into their buildings. They're doing that in part to save costs and to be able to improve occupancy in their buildings, but they're also doing it because the insurance companies want to be able to manage that risk with the CRE companies. So insurance companies are now providing sensors into CRE and high-value customers to retain that business, to reduce that insurance premium. It turns out if you have one water leak, then you're probably more likely to have another. And this is the second largest payout to natural disasters. So to be able to better manage that risk, insurance companies are now providing sensors like multi-tech water leak sensors to customers in order for them to maintain that insurance coverage. So convergence plays a crucial role in the Internet of Things, IoT ecosystem. It enables IoT devices to connect to various network platforms and their applications to seamlessly facilitate data exchange into automation platforms for enterprises and industries. Convergence offers several benefits. It enables the right telco wireless technology to be used for a different class of asset, so an automated guided vehicle versus a sensor in a refrigeration unit. It enables core networks like private cellular networks to create slices that can be more efficiently provided to assets that are maybe focused on range and battery performance versus broadband low latency connectivity. It enables enterprises to converge all of their data into a common platform. And it enables that data to be presented in a way in which application developers and AI algorithms can immediately make sense of that data and incorporate it into automation systems. So thank you for listening. My name is Daniel Quant, Multitech Systems. This is IMC Days Fall. If you'd like any more information, please contact us at multitech.com.
Thank you, Daniel, and thank you to all of our presenters today and to our audience as well. We'd ask that everyone please join us tomorrow for the third track of our session, which will discuss flat rate connectivity plans, as well as an antenna's first look at IoT projects. So please join us tomorrow for those interesting topics. Thank you very much to everyone, and have a great day.